As an example of a mass balance, let's go ahead and do a mass balance on this lake. Okay, so I'm up here at Scout Camp with my troop, and the boys want to have an appropriate level in the lake for their canoeing. Okay, so you can see swimming and canoeing, small lake. Let's go ahead and do a mass balance on this to determine if we can predict the level in this lake. So in walking around the lake, one of the things that we notice is that we come across this outlet drain, and the water level is not high enough for the water to be flowing out, so we can first of all assume there's no outflow from this lake. Okay, so here we're coming up on a stream that's flowing into the lake. Okay, so this is our inlet term, and we'll have to account for this flow coming in. We'd want to estimate this flow to know how much is coming in. That's going to be an important part of our equation. Okay, so this looks like the only inlet flow to the lake that we have. We have possibly another one right here as well, flowing into the lake, so maybe possibly a couple different inlets coming in. Now that we've discovered our inlets and outlets to the lake, we're going to do a material balance of the lake, or mass balance. We actually call it a plake, which is a pool plus a lake. Okay, so I'm going to go ahead and write a diagram of the lake with the outlet flow and then the two inlet flows that we had coming in. The two streams are right next to each other. Okay, and then we also have evaporation. That could also affect the level of the lake and maybe seepage as well. Okay, so what I'm going to do is go ahead and write my overall balance equation, which is accumulation equals inlet plus generation. And okay, now these are going to make the level of the lake rise. Those have a positive sign. And then outlet minus consumption, and that's going to make the level drop. Okay, so I have a negative sign for those that make it drop and a positive sign for those that make it rise. So my accumulation equals in minus out. I'm going to have zero generation or consumption of water within the lake itself. Okay, then I'm going to go ahead and write out my inlet terms and then my outlet terms as well. So evaporation and seepage, those are outlet terms, and I had the two inlet streams. I don't have any outlet flow. I would if the level rose and it got above a certain level. It would flow through the outlet drain. Okay, so I'm going to write rho, which is density, and V, which is the volume. I'm going to relate that to level, write my differential equation in terms of level, and then also have switch over to a volumetric flow instead of a mass flow. Typically we measure flow of liquids in volumetric flow. Okay, so then I'm just going to write out the evaporation and the seepage. So there's my differential equation, and you can go ahead and cancel out the densities as well. So you can just deal with an area of the lake and the level. Okay, so this is all that we wanted to cover in terms of the differential equation. And we say so long from Camp Maple Dell, where all of the scouts are above average.